Hold on to your hats, folks, because we've got news from the cosmos. Astronomers have just announced the discovery of an exoplanet that has everyone buzzing. This isn't just any exoplanet, mind you. This one is special. It's being called Earth-like, and for good reason. This new world, dubbed Kepler 186f, not quite as catchy as Earth 2.0, I know, orbits a red dwarf star about 500 light-years away in the constellation Cygnus. Now, 500 light-years may sound like a hop, skip, and a jump, but in cosmic terms, it's practically next door. What's got everyone so excited is that Kepler 186f sits squarely within its star's habitable zone. You might know this as the Goldilocks zone. More on that later. This means that the planet's surface temperature could be just right for liquid water to exist. And where there's water as we know it, there could be life. This discovery is a game changer. It tells us that planets like ours in the habitable zones of their stars might be more common than we ever dared to imagine. Now, before we get ahead of ourselves, let's talk about what we mean by Earth-like. It doesn't necessarily mean this new planet is covered in oceans teeming with life or has continents just waiting for us to explore. Not yet, at least. When astronomers say Earth-like, they're referring to a planet that shares some key characteristics with our home planet. These include things like size, mass, and composition. Kepler 186f is just slightly larger than Earth, and is thought to be a rocky planet just like ours. This is huge! A gas giant like Jupiter wouldn't be very conducive to life as we know it. We need solid ground to stand on, folks. But remember, even with these similarities, Kepler 186f could be a completely different beast. It orbits a red dwarf star, which is much cooler and smaller than our Sun. This means that Kepler 186f's year is much shorter than ours, clocking in at just 130 days. Let's talk about the habitable zone, or as I like to call it, the Goldilocks zone. You see, in the vast expanse of space, not just any old orbit will do if you're hoping to harbor life. A planet needs to be just the right distance from its star, not too hot, not too cold, but just right. If a planet is too close to its star, any water on its surface would boil away, too far away, and the water would freeze solid. But in the Goldilocks zone, the temperature is just right for liquid water to exist on the surface. And as we've already established, liquid water is essential for life as we know it. Kepler 186f's position within its star's habitable zone is what makes this discovery so exciting. It's a tantalizing clue that we might be on the right track in our search for life beyond Earth. Now, Kepler 186f isn't the first exoplanet to get people excited about the possibility of life beyond Earth. Oh no, not by a long shot. In fact, in just the past few decades, astronomers have discovered thousands of exoplanets, and some of them have been pretty darn interesting. Take Proxima Centauri b, for example. This planet orbits Proxima Centauri, the closest star to our Sun, a mere 4.2 light-years away. Proxima Centauri b is also thought to be in its star's habitable zone, making it another prime candidate for life. But let's not forget about TRAPPIST-1e. This planet is part of a system of 7 Earth-sized planets orbiting a star about 40 light-years away. 3 of these planets, including TRAPPIST-1e, are in the habitable zone, and some scientists believe they could have oceans of liquid water. The discovery of Kepler 186f adds to this growing list of potentially habitable exoplanets, telling us that we're likely not alone in the universe. Section 5. Signatures of life. What makes a planet habitable? So, we found a bunch of planets in the habitable zones of their stars. That's great. But how do we know if they're actually habitable? What are scientists looking for when they're trying to determine if a planet could support life? Well, it's not as simple as just checking the temperature. There are a whole bunch of factors that come into play. It's like a cosmic recipe, and you need the right ingredients in the right amounts. First and foremost, we're looking for the presence of liquid water. It's the universal solvent, essential for all life as we know it. But it's not enough to just have water. It needs to be present in liquid form, which means the planet needs to have the right temperature and atmospheric pressure. Section 6. Water, the elixir of life. Water everywhere. But is it the kind we need? That's the question scientists ask themselves when they're assessing the habitability of a planet. And it's not an easy question to answer from millions or even billions of miles away. We have to play detective, looking for clues in the faint light that reaches us from these distant worlds. One thing we look for is the presence of water vapor in the planet's atmosphere. This can be detected by analyzing the way the planet's atmosphere absorbs and reflects light. Another clue is the presence of clouds. Clouds on Earth are made up of water droplets or ice crystals, so finding clouds on an exoplanet could be a good sign that liquid water exists on the surface. Of course, clouds could be made of other things, but it's a start. And then there's the search for oceans. Now, we can't exactly see oceans on exoplanets with our current technology, but we can look for the glint of starlight reflecting off a large body of water. It's a long shot, but hey, in this game, you take what you can get. Section 7. Atmosphere, the protective blanket. Water is crucial, yes, but a planet also needs a decent atmosphere to be considered truly habitable. Think of it as a cozy blanket that helps regulate temperature and protect life from harmful radiation. Earth's atmosphere is a delicate balance of nitrogen, oxygen, and other trace gases. This mixture is just right for us. It traps enough heat to keep the planet warm, but not too much to turn it into a furnace. It also filters out most of the sun's harmful ultraviolet radiation. When studying exoplanets, astronomers look for signs of an atmosphere and then try to figure out what it's made of. They do this by analyzing the light that passes through the planet's atmosphere when it transits, or passes in front of, its star. Different molecules absorb different wavelengths of light, creating a unique fingerprint that tells us what the atmosphere is made of. Finding an atmosphere with the right mix of gases would be a major step towards confirming the habitability of an exoplanet. Section 8. Magnetic field, shielding life from cosmic rays. Here's something else to consider. A planet's magnetic field. You might not think it's a big deal, but trust me, it is. Earth's magnetic field acts like a giant shield, protecting us from harmful cosmic rays and solar wind constantly bombarding our planet. These high-energy particles can be extremely damaging to life. They can strip away a planet's atmosphere, irradiate the surface, and even mess with the very building blocks of life, like DNA. Unfortunately, detecting magnetic fields on exoplanets is incredibly difficult with our current technology. But scientists are working on it. New telescopes and techniques are being developed that might allow us to detect these protective shields in the not-too-distant future. Section 9. The promise of Proxima Centauri b. Let's go back to Proxima Centauri b for a moment, shall we? As I mentioned earlier, this planet orbits the closest star to our Sun, making it a prime target for future observations. What makes Proxima Centauri b particularly intriguing is that it's close enough to Earth that we might be able to study its atmosphere and look for signs of life within our lifetimes. Of course, there are still many unknowns. We don't know if Proxima Centauri b has an atmosphere, let alone what it's made of. And being in the habitable zone doesn't guarantee habitability, but the potential is there, and that's what makes it so exciting. Section 10. Future telescopes, unveiling the secrets of exoplanets. The discovery of Kepler 186f and other potentially habitable exoplanets has ignited our imaginations and fueled our desire to learn more. The good news is that we have even more powerful telescopes on the horizon, ready to reveal the secrets of these distant worlds. The James Webb Space Telescope, for example, is set to revolutionize our understanding of exoplanets. With its advanced instruments, it will be able to study the atmospheres of exoplanets in unprecedented detail, potentially detecting signs of life. And then there's the extremely large telescope, currently under construction in Chile. This behemoth of a telescope will be the largest optical/near-infrared telescope ever built, capable of directly imaging some of the closest exoplanets. These are just a few examples of the incredible tools that will soon be at our disposal. With each new generation of telescopes, we'll get a clearer picture of the universe and our place within it. Section 11. A universe of possibilities. The quest for life continues. The discovery of Kepler 186f is just one small step in our long journey to understand the universe and search for life beyond Earth. It's a reminder that we live in a vast and mysterious cosmos, filled with endless possibilities. While we don't yet know if we're alone, the sheer number of stars and planets out there suggests that life might be more common than we once thought. And with each new discovery, we come one step closer to answering that age-old question, are we alone? The quest for life beyond Earth is one of the most profound scientific endeavors of our time. It's a journey that will continue to inspire and challenge us for generations to come. And who knows what incredible discoveries await us in the vast expanse of space. Stay curious, my friends.